Hello and welcome to this presentation on WinJS, or the Windows library for JavaScript. I do assume that you have looked at the earlier video or presentation on the WinRT or Windows Runtime. This video is a continuation, or sort of the next phase, if you will, from that video. So we won't be looking at WinRT over here, even though we might be using, of course, parts of the WinRT. The idea is to focus this presentation primarily on WinJS. So the WinJS is essentially your gateway into the Windows RT application. So, oops. So through WinJS, you have access to the WinRT APIs, the file system, various other pieces of the WinRT API, and also the Windows IE DOM, if you will, the HTML DOM and other JavaScript that you're typically using. We'll be focusing primarily today in the sort of the WinRT side of things. That is not just the WinRT aspects, but also the WinJS library provides a lot of features and functionality in addition to access to WinRT. Features like XHR and promises, akin to jQuery, if you will. So that's what we're going to be looking at in today's presentation. The Windows WinJS is comprised of course, multiple toolkits, as you see here on the screen, and we're going to be looking at some of the toolkits in today's presentation. We'll be looking at the WinJS core, not directly, but sort of indirectly, of course, since the core is used in pretty much everything else. And then we'll be looking at promises. WinJS promises are an implementation of the CommonJS promises of a spec or specification, part of the CommonJS.org website. You can take a look at it over there. And essentially promises are asynchronous method support, just like we have in C# 5, .NET 4.5. We have the async await capabilities, or task of T. Return types, or in the WinRT we have the async operation of T type. That is the sort of the asynchronous methods in WinRT. The WinJS promises are the support for asynchronous operations in JavaScript. We'll be then looking at building our own user controls using JavaScript, and of course implementing binding capability with the controls. So we'll be looking at binding, and then we'll be looking at some of the Windows 8 personalities, such as the list views, as well as implementing some contracts like the search contract. We'll be looking at the app bar control as part of the Windows 8 personality controls, and if time permits, we'll be looking at the navigation model. What we won't be looking at, or the toolkits that we won't be looking at, are the animation toolkits, the platform controls toolkits, and the utilities toolkit. So without further ado, let's go start with the promises in WinJS. Okay. So what I have here is a solution with a bunch of projects, and what we're going to be doing is we're going to start with the promises project, and then we look at the custom controls project and the search contract project. This promises project is essentially just I've done a file, new project, and then we looked at the Windows Store application, and within the Windows Store application I've selected a blank application. So that's really what I've done here so far. Now the in the blank application, actually it's probably, that's literally what you have here. This is the point at which, let me zoom in. This is the point at which your application kind of starts the onload, if you will, of your application. So anything you want to do at the start of your application, you kind of write the code over here after your set promises method call here. Now, you of course don't want to do anything that's long running, because that will delay the startup of your application, but that's kind of the hook into your start. What I'm going to do is I'm going to just wipe the slate clean. So I've deleted all of the JavaScript here. By the way, don't try this at home. I am a trained professional, so I know exactly what I'm doing, but you will too soon. So what I want to show you here is what we had, the stuff that I deleted, but I want to kind of show it to you from the beginning so you can see what it is that was there. So this is in JavaScript. This is known as an anonymous function, and it says self-executing, and this is calling itself self-invoking or self-executing anonymous function. And we do this in JavaScript. Nothing to do with Windows 8, by the way. It's just JavaScript to prevent polluting the global namespace. In JavaScript, we have pretty much everything we do is in the global namespace. So unless we have a local variable defined with a var inside of a function, it's local. But if you just define a variable, it becomes global. Of course, all functions are global by the nature of the fact that you just write it in the global namespace. So having a self-executing anonymous function allows us to have everything inside of this function to be kind of curtailed or within the confines of this function, so you can't see them on the outside. This is good practice, if you want to be a good citizen in the JavaScript world, then you want to make sure that you don't pollute the namespace, the global namespace, with all kinds of variables and functions that are accessible on the outside. Of course, then you wonder how would you make things available on the outside from within these anonymous functions if you so desired. And there are ways. In WinJS, they have introduced the notion of namespaces that allow you to define things inside of namespaces, and then you can access those things from the outside by referencing the namespace dot the class or the variable type or whatever the variable name that you wanted access to. We will look at that at a later in a later demo within the same video, or probably the next. But for now, we just want to look at anonymous methods. So before we can start here, I need to have access to my application, and we get access to a reference to that instance using WinJS.application. Once we have access to this instance, we want to subscribe to some methods, in this case the activated method, and that's sort of hooking into the onActivated event. And then we want to obviously start our application. The idea is that you want to first hook into the events, and then you want to call the app start method so that you had the opportunity to hook into all the events you're interested in before you start the application. So if I would run this application and put a breakpoint here, it would come and stop over here. So just to, because this application is doing nothing, so if you couldn't run it, it's just going to be a blank screen. That's all you're going to see here. So okay, so promises. As I said earlier, promises are asynchronous methods that return data at some point in the future. And a promise can be looked at as an IOU, which says, I'm going to do this, and I owe you a result sometime in the future. They're asynchronous, so typically you use promises for IO-bound asynchronous workloads, such as making network calls, accessing the file system, and so on. But it's also possible that you might want to make promises of your own that are not necessarily asynchronous in nature, but in order to conform to some method's requirement, if the method requires for you to provide a promise, you might need to create a promise out of something that's not necessarily asynchronous IO, but this is nonetheless a promise. So we'll be looking at some of those things as well here. I think the simplest way to explain, or for people to see what a promise is to work with something that's familiar to you. And I think the XML HTTP request object, which is what everything Ajax uses behind the scenes, I think people are familiar with. I want to use that here and show you the sort of asynchronous capabilities or the promise capability in WinJS using the XHR object. So you have access to the XHR object, which is nothing but WinJS.xhr. This is a method that essentially wraps the XML HTTP request object around a promise. So what you get back from this is a promise. And of course you call it with some parameters. And I'm going to download the HTML from my blog here. And this essentially is a promise. So the WinJS.xhr method returns to us a promise. And all promises have a method on them called then. That's like the task dot continue with in C#. And in the then, you have a bunch of methods, the completion method, the error method. Right now, we're just going to look at the completion method. So it's a function that gets an XHR. Now, one thing to keep in mind is as soon as this line was executed, the XHR, the downloading of this, in this case, URL has already begun. It's not like it's waiting for you to execute or start. It's not like a thread start, if you will. It's already taken off. It's already in flight, as they call it. And you decide when you want to extract the result of that. So when you call then, that's the time the result is available to you. Now, the result may not be available to you at that moment in time. And so therefore, execution will continue on past this method to the next methods here, if you will. And eventually, at some point, when this method does complete, the asynchronous method does complete, it'll call this function for you over here. So to get an idea of that, let's look at the sequence of steps. So I'm going to put a breakpoint here, which is the end of this this function. And I'm going to put a breakpoint here. Let me actually write some code in here. XHR dot response text will give us the HTML from my blog's website. Okay, so I'm going to put a breakpoint in here. Now, because this method is asynchronous, so this method itself is asynchronous, it won't stop here. It's actually going to stop here first, because this will be done. And then it'll call back into this method eventually when the downloading of this site is complete. Let's ensure that's what's happening here. So you see it comes in here first. It's sort of skipped over this because this is asynchronous. It's not a blocking call. And then at some point in the future, when I continue running, I'll see that this HTML is, let me put a breakpoint here. This HTML actually contains the HTML from my website, starting from the beginning of the page, etc. So just so you see that. Okay, so what we were to see here was that the promises are asynchronous in nature, in that you make the call, and as soon as you sort of instantiate a promise, it's doing its thing, it's in flight, and it's when you call then that you get the result of this this call. So if there's work to be done beyond this promise.then, those methods will be called, and at some point it might just sort of break away from there and come back and call this method and end up over here. So you can't necessarily predict when that's going to happen, but just so you know that it's not a blocking call. It'll call it when it's done, and you can do whatever processing you need to do when that method is called. Okay, so if that takes care of the simplistic approach to promises, of course we haven't looked at some of the other capabilities or possibilities. That is, what if there was an error downloading this this URL here? So let's look at that. So as you saw here, the method takes on three parameters: the completed function, the error function, and the progress function. So we look at implementing those here. So if that was and to keep it sort of more legible, I'm going to call this completed, even though you don't need to give it a name. And I'll this function as error, and this function as progress. Okay, so let me also just define some variables here, so you can put breakpoints. Okay, so now there's no errors here, but nonetheless the progress event will be called, in this case a callback. Now it's not going to show you in terms of percentages, it's just going to show you in this case, because the XHR object supports different statuses. It's going to show you different statuses, and eventually when it's completed it'll call this method here. So we'll see that take place. So run it now. It comes in here. You can see that the XHR's status is a 2, which essentially means that the HTTP headers have been received, and the next thing it's going to do is start downloading or receiving the data. Now we see it's a ready state of 3, which means it's receiving this HTML from this website. That might keep going on for a few seconds, I'm hitting F5 to run it. It keeps calling this back, and eventually it comes in here in the completed. And at this point, we have the HTML in our. I can't use my F10 key here because of the recording, but there it is. So that's the HTML. So now, if there was an error here, let's see what would happen. I actually can't create errors in my website because no matter what page I type in, it's going to return the home page in case it didn't find it. So, but if I went to Google, that was by design, by the way, honestly. Now, if I go to Google, I could go to abc.html and actually will give me, no matter what it is, it'll give me a 404 not found, which I think is a waste. But so I run it again, and besides the few times it's going to call, it eventually comes here with the error method. And in this case, you can see that the ready state is a 4, which means it's done, it's completed, but there's a error, HTML, in the form of HTML. And if I scroll down, I'll see the status is a 404, which means it's not found. Right? Okay, so that's cool. So what would happen if we didn't have this exception handler here? So this error method here. So let's check out that feature. So I'm just going to go back to the way it was before, right? So without the error callback. At this point, what would happen is, because of some error that could potentially take place in this HTTP call, the application actually will terminate, and you're going to come in here, which is in the base.js JavaScript file, part of the WinJS library, and we end up here in the terminate handler. We can see that there's a problem here. We just don't know exactly where this happened. This actually brings me to the point where I can explain to you another feature, another thing that you might want to do. In WinJS, your application also has a on error. This is like a catch-all or global exception handler. So in case any exception escapes your program, it can be trapped in this global exception handler. Let's call it exp. And so if we run this again, let's just put a breakpoint so you know it doesn't come in here. It goes in there and actually terminated the application. So it should have gone into our app on error event here. Let me see why that would be the case, why I didn't do that. Okay, I had a debugger setting on that was preventing that from happening, but so I'm just going to run this again. Well, actually what's happening is when I don't put this breakpoint here. Okay, so there it is. So it stops here, and if I don't return a true here, it's going to go back into the debugger anyway. So that's what had happened here. So if I return this, return a true here, this is the global exception handler. You want to return a true unless you know what you're doing. But just to show you here, the application should continue to run, which is what we wanted. So now the application is running. Of course, we don't necessarily see anything since it's a blank screen. So that's one way to do it, but there's a sort of a more recommended way of handling errors in promises, especially when you might have multiple promises being called. In this case, if you have just a single method that you want to call here, as in there's not multiple promises here, then rather than calling the then method, you should be calling the done method. It has the same signature as the then method, but the done method is sort of the final step. At the end of all of the promises, if you're chaining promises, then you want to call the then method, the done method. And if you have only one promise and you only intend to call the one promise, then rather than calling the then method, you should call the done method. And the done method is different from the then method. Gosh, I'm having such a hard time with this. Because the then methods return another promise, while the done method just returns an undefined, so it's not returning anything. In other words, it's kind of indicating to you that it's the last step, and so there's nothing to be returned. However, if you do have an exception in the then methods, then the exception is raised in the event loop, and so they won't be caught by try catches, and that's kind of like the difference. Whereas with the done method, if there's an exception, of course the done method also has the same signature, so you would have, the same thing happening here. This throws an exception, and you can actually catch if you don't have this function, it throws an exception. So it's not in the event loop, but it's actually an exception, so you can catch it in try catches. But the idea is that if you are only calling a promise, that you're not chaining promises, then use the done method. And I actually could show you an example of that. So let me finish my thought here. So just keep that in mind. There's a difference between the then and the done. The done does not return a promise. The then does return a promise. The done returns an undefined, and you typically use the done method if that's the only promise you have, or while you're chaining promises, the last promise is, you call the done on it rather than the then on it. Okay, now we're going to switch gears a little bit. We kind of go backwards some, in that we look at building our own promises. Just like in C#, you have the task completion source that allows you to create a sort of a fake async operation, an async method. Without actually doing something asynchronously, you can return an async operation. In WinJS, we have the similar capability. So I'm going to have a promise that is nothing but a new WinJS.promise, and in this case I need to send in a function that has 3 callbacks: the completed, the error, and the progress. And of course I'm going to implement something here, but it's not going to be asynchronous. It's not going to do any file I/O or network I/O. So I'm just going to kind of fake it. But what I want to do is I want to say, okay, well, I'm done. So here's your value. And because I don't want to throw an exception or call the exception method, I'm going to call the completed method, and I'm going to give it a value. In this case, let's say 42. I can then use this promise and call the then, or in this case, because it's only one, I'll call the done method. And in the done method, I'll call the completed method here, which is the first parameter. And in here, I'll have this value, which is 42 in this case. Now, let me also display this in the HTML. Oh, we already have this div in here that has a size of 36 font size, so you can see it. I'm going to use this div, and I'm going to set the text content of this div to the value we get from our promise. So if I run this, you'll see that I get 42, which is good, because that's what we wanted. Now, if I want to make this like a delayed response, right, because it's asynchronous, so I could have, let's say, after this promise, I could div content. I've never tried this before, but maybe I do a plus equals, and over here I just say hello. Right? And so the idea is that the hello will be printed out to the div before this finishes, but I want to kind of delay the actual promise here. So I could do a set timeout with the callback, and this callback is this method here. So after a certain period, which should be 2 seconds, so 2 seconds later, it'll call the completed method that returns the value of 42. That means it'll call the then method here, and it'll then add to whatever the content div is the value 42. So it should say hello 42. I hope. I've never tried this before, but this is always the first time. So hello 42. So 2 seconds later, we see 42. So that shows you also that this asynchronous nature, where this method was called before the callback, or the promise method was called. Now the promise in WinJS also has this functionality is actually built in, so I don't need to do it like this exactly. I could do it in a simpler fashion, which would be promise.timeout, and the timeout takes the delay, which is 2 seconds, and .then, which takes in a function which may or may not have a value in this case, of course, but what I can do is I could then do what I want, and in this case, this of course is the complete method. It takes the same three methods: the completed, error, and the progress. So here I can return say 42. So that's sort of the same thing we were doing before, except it's done slightly differently, with the timeout being handled by the method in the promise itself, making it convenient, and we're just returning what we need to return here. So we should see the same output. Hello, and then 42. There you go. So now, as I said, the promise has other methods. So let's look at one of the other methods. You could say promise.wrap, and you can wrap it with 42. Of course, this could be a string as well. It doesn't have to be 42. It could be anything. This is JavaScript, so you're not bound by any specific type here. It's dynamic. So, and this should have the same result, except there'll be no delay. So you might actually see 42 and then hello. I'm not sure. Let's check out what happens here. Well, I guess we made a mistake. Yeah, I think what's happening is that it's coming here first and then coming here, and so we're not seeing the value here. We're just seeing the hello. So let's verify that. Okay, so it's coming here and then it comes there. So what we end up seeing is hello, but we don't ever see the 42. But it did put the 42 in there. Should probably do this plus minus like this, so it might be 42 hello. There you go. Okay, so that now the wrap, just like the wrap, there's also a wrap error. So you can have, if you want to wrap as an error 42, you can do that as well. Now what I want to show you is two techniques, or the notion of chaining promises, and sort of show you the right way to chain promises, and also using the then or the done function instead of the then function for the sort of the last chained promise. So I'll have a promise 1 here that wraps 42. Actually, instead of 42, let's make it 10, 20, 30. So we have 3 promises. Oops, 2, 3. Let's delete all of this. I don't need this for now. And so now if I want to chain promises, I could do promise 1 dot then function value, right? And then in here, inside of this promise, when this promise gets called, I can then call promise 2 dot then, and so on, right? So there's nothing wrong with this. It's going to work, but the idea is that this could get pretty hairy, because as this is being nested, right? So in jQuery, this is kind of like how you would do things, where things get nested quite heavily, and it becomes difficult to read. At least for me, I find this very difficult to read all these nestings. I'm not sure what's really going on. So in WinJS, they also allow you to chain promises in a slightly different fashion, and I think it's a lot more readable. So instead of doing this, what you could do is you could say promise of 1 dot then. So no change so far, and over here. But instead of having the nesting happening in here, you can just do dot then on the outside, and promise dot then. And then over here you do return promise of 2, and then you do dot then, and then here you do return promise of 3, and so on. Right, and then for the final one, we do done, breakpoint. So, oops, sorry, this doesn't. So this is an easier way to read things, where you're calling promise 1, and then you call or return the promise 2, and then you return promise 3, and eventually you're done. Not the then, but the done. So the final one, the done, is always at the tail end of the chain of promises. So if you were to look at, let me put a breakpoint in here. Actually, let's put a breakpoint on all of these so you can see it all work. This will work too, but we're just looking at this one. So it comes in here with a value of 10. F5 comes in here with a value of 20. F5 comes in here with a value of 30. So what we have here is all the 3 promises are done eventually. Now, if there were an exception here, as I said, the done method will convert the exception into an exception that you can sort of try catch. So if you call done and there's an exception anywhere up here, so let's convert this first one here to a wrap error. In other words, as soon as we call the first one, there's an exception, there's an error. So how do you handle these exceptions or errors when you're in promises? Now, if you don't use the done, then what happens is the exception is inside of another promise, and that just gets lost, as in it's almost like a swallowed exception. And you don't want that. You want to make sure that when you have chained promises, that the last one calls done, so that you have an option or the opportunity to catch the exception by way of implementing a, an exception handler, if you will, callback. And this is where the exception is going to happen, or will be trapped here. So you get the opportunity. So let's do. Now, you still have to return a false or true if you want to actually handle this exception without it blowing out and going into the global exception handler, or killing your application in case you don't have one of these. So let's see. Whereas over here, nothing would actually happen. So if you put a breakpoint here, okay, I guess we need to do more than, but you'll see it doesn't actually stop here, and over here it should come into. I'll put breakpoints all over here. So this is the completion handler, and this is the exception handler, right? The Y. So we run it here. You see, it didn't do anything here, even though these methods are being executed. You didn't actually see the exception, or there was no opportunity here to catch it. And this exception has kind of just gotten lost. It's actually gone into the event loop, and it'll eventually bubble up and kill your application. But because we're using the done method here, even though the exception actually happened in the first promise, the done sort of bubbles that exception up to the done method, and you actually have an exception opportunity here. Of course, now we didn't return a true, so it'll still go into the global exception handler if we have, of course, we returned true here, so we didn't see that. So it came in here, and then I guess we had the opportunity to catch it, so we don't need the exception handler. So that's the big difference really with the chain promises. So one is, don't do the chaining of promises, even though it works. It's not the best way to read it, but also prevents you from being able to, well, you could call the then here, the done here, sorry, and that would have the same effect, but it just gets too complicated. With this style, you have the opportunity to chain promises without nesting them, and the final method, final promise, you can call the done method on it, providing it the exception callback, and you can handle your exceptions over here. So that takes care of the simpler promises, where you can use some of the methods on promises such as wrap, timeout, and wrap error. Chaining promises using the done function and the difference between the done versus the then. And now we're going on with promises, but look at something a little more real world. Okay, so let's clean up all of this stuff. Okay, so we're back to a clean slate. Now I have a bunch of URLs here, and these URLs are nothing but images to images on my Azure Blob Storage. And one of these images, this guy, is actually bigger than the other images. So this is pretty big. It's a pretty big image. as you can see here, compared to, let's say, this guy. So anyway, keep this in mind because we're going to look at doing some stuff with these URLs and images in an asynchronous manner or using promises. So what I want to do is I want to create a promise for each one of these URLs. And this promise then allows me to do, download these images asynchronously, and I can operate on them in an asynchronous fashion. So first let's have XHR promises that are created using urls.map. So urls.map is a method that it kind of iterates over each of the URLs, that provides a callback, that provides the singular or each URL. So each time, for every URL, this function is called, passing in the current URL it is iterating over. And in here, what we can do is we can return a WinJS.xhr that takes in this object, a URL. Well, in this case, the property name is URL and the variable is URL. And that's essentially a WinJS is being returned as an array of promises. So for each URL, there's a WinJS promise being returned in this collection here. So the XHR promises is nothing but XHR promises. So we have a collection of XHR promises here. Now we can operate on these promises separately. Now, one of the things I want to talk about or do with these images, I want to actually download these images and assign them to an image tag in the HTML document. Now, with the XML HTTP request level 2 specification, which kind of came out simultaneously with or very close to at the same time with the HTML5 specification, they enhanced the XML HTTP request object to include different kinds of data uploads and download capabilities. And one of them is the ability to download data as an array buffer or a blob. Of course, if you intend to manipulate the array buffer in terms of at the byte level, then you want to download things at the array buffer as an array buffer. If you intend to just download things as a blob and retain the data as is, such as we are trying to do here with images, you can use the response type of blob. So what I'm going to do here is say response type of blob. Okay, so what that's going to do is going to download these images not as text or XML as we would have been able to do before the level 2 specification came out and was implemented by various browsers. Chrome implemented level 2 specification, I think in version 9, so a while back. IE 10, in this case we're using IE 10. IE 10 also supports it, so we have access to be able to download data as blobs and array buffers and JSON and documents and text. But in this case we're now using the blobs. So these promises are actually downloading these blobs asynchronously. Okay, so now what we want to do is we have WinJS.promise.any. So any is one of the methods that says, well, given an array of promises, call me back or call this method, the then method, when any one of these promises is complete. Now we know that this first image is larger than the other, so ideally we would expect one of these images to be downloaded, in this case the avatar image or the Sherlock Holmes image, as against the first one here. Of course, we've cached this image right now by showing you the image itself. It's been cached, and so we may not get the behavior we need, but let's first implement it and then we can see if we can fix it. So the idea is that any would not wait for all of them to be downloaded. It'll call this method as soon as the one is available. So let's call this first XHR, the parameter, so whichever one is the first. And we have a blob here that is going to be first XHR dot. Now in reality, or for the most part in other methods, the response, because we said response type is a blob, the response would be a blob. But in the case of any, that doesn't kind of work out as one would think. So what I found, for some reason, you have to do value._value.response. That makes it, that gives us the access to the blob. But in the other methods, actually it works. So any is the sort of the oddball in this case. So once we have a blob, we want to create an image tag on the fly. So it's document. So this is standard DOM, even though in WinJS, as I said earlier, within the WinJS access, you also have access to the DOM capabilities. So document dot create element. In this case, we create an image tag. And to the image source attribute, we want to assign this blob, but of course the source is a string. And so now we have a function URL create object URL given the blob. So we have essentially what this method is doing is it's taking this blob, the binary information, is saving it to the temp file system. It then gets a URL, if you will, a file path to that newly created files in the temp file system, and assigns that to the source property. It essentially makes it like a good file name. And the API, of course, prevents us from having to know how to access the local file system or the sandboxed file system, and so we're just dealing with it at an API level. So once we have the image assigned to the source, we can say document dot body dot append child and assign this image tag to that, and we should see the image. Now, as a good practice, what you want to do is, once you've assigned the source and the image is loaded up in this image tag, you want to free up the file name, if you will, and the blob. Okay, so to be good citizens here, what we want to do is we want to image dot add event listener to the load method of load event of the image, and in here what we can do is evt dot whether it's source element dot target, or is it target dot, hang on, let me see what would be. So actually event dot target dot source. What I want to do is, there's another method here for the URL object, which allows you to free up, if you will, release the name of that file name, so you can use the event.target source. Event and target is the image tag, and the image's source is the same source. So you're allowing it to free up or reuse, if you will, that image name and the resources associated to that. So once it's in memory, once the image has been loaded, you don't need the actual physical file to be present on the machine. So this is just good practice. So what we should see here is, when we run this, an image tag is being created on the fly and is assigned to or added to the body's child. Body as a child of the body, and so we should see the image appear. Now, because we still have the issue with the fact that this image is probably already cached. So let's see what happens here. Well, sure enough, so the very first image that came down, not that it actually came down, but the any is the first one here. So what we need to do is take into account, so here we do headers, and if modified since return something. So the if modified since header, if you're not aware of the HTTP headers, an HTTP client, when it makes a request on the server, if it sends the if modified since header, says, well, if this resource has been modified since a certain date, then don't bother sending it back to me, I'll pull it from my cache. And so what we're doing is we are sending in the -1. It could be anything else but a date, and the server would say, well, yeah, it's not modified, or it has been modified since whatever that is, so I'm going to send you back the image. So the -1 is just a nice way to remember, not to send a date in. But if you send a date in, then the server will compare the date with the date you send in, and if this resource has been modified since that date, then the server will send you back the response. It won't send a 3 or 4, but it'll send you a 200 with the actual content. Let's see if that helps us here. I guess not. Well, maybe I made a typo mistake. Yes, actually it's headers, not header. Okay, so now we see that the avatar image is being downloaded instead of the bigger one here. Now, of course, these two are, I would think, the same size, so they could come down interchangeably. It's not necessarily that the avatar one will come in first. So, but at least it's not the big one. So the any works in that fashion where we wait for any one to come down. Now, the other possibility is that we want to wait for all of them to come down. In that case, we say promise.join. This is the same or similar to thread.join in Win32 or in even in C#. You have a thread.join, which essentially waits on other threads to finish and join up. So in this join, what we get is thread.join takes in the XHR promises dot then, and what we have here is all of them. So in here we'll call them XHRs, if you will, all of the entire collection. And for I equals XHRs dot length, do something. We could pretty much copy this whole thing here, and so I'm just going to copy it blatantly and change a few things. So this would be, instead of first XHR, it would be XHRs of I. So XHRs of I, and then let's see. Oh, and as I said, the nuance here of this dot value only pertains to the any, so we don't need that here. We can just do XHRs dot response. That's the blob. Everything else should, I think, remain the same. So we'll get one image for this one, and then we'll get all three of them for this one. In this case, the sequence or the order in which the images will appear is as they have been defined in this array over here. So, must have made a mistake. But you notice here that the, in this case, the Sherlock Holmes one came down first. Let's see what the error was over here. XHR promises for I. Okay. Well, let's just run it again. Okay, so there we go. So now what's happening here is, actually what you didn't see was I commented out the earlier one. So let me just resize this image so it kind of appears similar to the other one. So I can leave this up, it doesn't matter for now. So that's the any, and then this one. So over here, just to be sure, I'm also going to size the image, the width in this case to be 220, and do the same over here. Okay, so this is for the any, and then these three are, they're going to come in the same sequence as they have been defined in the array, so that's not a surprise. Okay, there's a third way you can use the promises, which is then instead of just doing any, you can do it then each, and explain to you what the then each will do. So the then each will essentially call each of these, this method here, so this function, and it takes in actually first of all the XHR promises, and the second parameter, the completion method. In this case, we just call it XHR, the singular. And so it'll call this method here for each. But again, in this case, the difference is that what the order, the sequence in which they are called is not predictable, but they will be called one by one. So whatever is in here will be called n number of times based on the number of promises you have. So we actually just want the singular version, if you will. Again, blatantly copy this code, and we won't need the nuance here again for the any, we just need this. So this should work. So XHR, this should be changed to XHR. That's the only difference, I think. Yeah. Okay, so now I'm just going to comment out this method, or maybe even this one here. We don't need to see this over and over. But keep in mind that the sequence may not be predictable here. So you can see this, the sequences have changed. Of course, we can kind of predict why this one is coming in last because it's the largest one, but these two may change or flip depending on what's going on. So maybe try it a couple of times to see if it changes. Well, no luck here. And again, yeah, there you go. So the Sherlock Holmes came before the avatar. And so that kind of confirms that the sequence is not necessarily, well, actually this one I already confirmed, the sequence is not predictable. Okay, so I think that takes care of the promises feature in WinJS, and now we'll be looking at some other capabilities.